So, good evening, students. Good evening, one and all. So, myself, Anandi, and today I am going to discuss the aldehydes and ketones lesson with you. It is one of the aromatic compounds lesson, and let's start with the lesson now. So, you can see some of the pictures here. So, this is vanilla ice cream which we used to eat, and a compound is present in it which is called as vanillin. And in the nail polish remover, you can see the compound acetone present in it. And this is the perfume which we use. And the benzaldehyde is present in it. And at the last, you can see acetic acid is present in the vinegar. Okay. So something is common for all the four compounds. What is that? Can you find out? Yeah, it is the C double bond O present in all the compounds. You can see here in the CHO, C double bond O is present, and in acetone, C double bond O is present here, and in benzaldehyde, it is present in C double bond O H, and acetic acid, it is C double bond O H. So today we are going to deal with the aldehydes and ketones. Okay, so under this, we are going to see introduction, preparation of aldehydes and preparation of ketones in today's class. Okay, let's start with the introduction first. So what are these aldehydes and ketones? So aldehydes and ketones have general formula of CnH2nO and contains C double bond O group, and those two aldehydes and ketones collectively they are called as carbonyl compounds. Okay, so both have the same general formula. So you can see here R C double bond OH. So to this C double bond O group, one side R we are having, and in the other side H group we are having. So this is represented as aldehyde. And in the other compound, in both the sides we are having R group. What is R group? It is alkyl group, right? In both the sides we are having the alkyl group. So it can be methyl, ethyl, propyl, etc. So if both the groups are alkyl groups, then it is termed as ketone. So today we are going to see about the CHO and COR compounds in this class. Okay, let's start with the preparation of aldehydes. So moving on to the preparation of aldehydes, we do have a number of preparation. Okay, so under this, the first topic is from acyl chlorides. We are going to prepare the aldehydes. Okay, so what are acyl chlorides? Acyl chlorides are C double bond O Cl containing compounds. So you can see here they are once again. So acyl chlorides are C double bond O Cl containing compounds. Okay, when this is treated with hydrogen in presence of palladium barium sulfate. So palladium barium sulfate is basically a catalyst. Okay, so when we treat acyl chloride with this reagent, it forms RC double bond OH, which is nothing but RCHO. Okay, it is the aldehyde plus HCl. So what is the name of this reagent, palladium barium sulfate? It is called as Rosenmann's reagent. So this reaction is termed as Rosenmann's reaction. Okay, so what is happening here actually? This Cl is getting converted into hydrogen in this reaction. So it's a very easy reaction, right? So this is how we prepare an aldehyde from the acyl chloride. Okay, we'll see an example to understand this. So let's take this CH3CH2COCl as a first example. Here the R group is ethyl group, C2H5, right? So ethyl group is the alkyl group here. When it is treated with the Rosenmann's reagent, it forms propanoyl chloride, reacts with Rosenmann's reagent to form the propanol. Why it is called as propanol? We have 3 carbons here. 3 carbon containing aldehydes are called as propanol. This you might have studied in the nomenclature lesson. Okay. So we'll see one more example, an aromatic compound example. So the name of this compound is benzoyl chloride. C6H5 C double bond O, Cl is benzoyl chloride. And on treatment with this Rosenmans, this chlorine group, this will be converted to the hydrogen. So what we'll get? We'll get benzaldehyde with the release of this HCl. Okay. So benzoyl chloride is getting converted to benzaldehyde. Okay. I hope you would understand this. So this is the first preparation. It is a naming reaction which is very important for your exams. Okay. So now let's move on to the second reaction. So second is from nitrites and esters, which are otherwise called as Stephen's reaction. So in Stephen's reaction, we are taking RCN as an example. Okay, RCN is the reactant, nitrile group here. So what is the complete structure? How to write this? R, C triple bond, N, right? So in this, if you add tin chloride with HCl. So this tin chloride and HCl is the Stephen's reagent. Okay. On treatment with this and on acid hydrolysis, we get an aldehyde. Okay, CN is getting converted to CH4. So how does this occurs? You need to study the mechanism, right? So first you take this RC triple bond N compound and make it to treat with this tin chloride and HCl, and it forms a compound like this. So how to get this compound from this? You have to actually this tin chloride and HCl is a reducing agent. Okay, reduction means addition of hydrogen, right? So break one of the triple bond here, add one hydrogen to the carbon and another hydrogen to the nitrogen. So you'll get this compound which is called as imine. And this imine on acid hydrolysis. Why we call this as acid hydrolysis? This contains H plus and H2O, right? So acid hydrolysis. On acid hydrolysis, all the component which is there after this double bond, they get converted to oxygen. So and then what we will have? RCHO plus NH4Cl. Okay, this is how we prepare the aldehyde from the Stephen's reagent from nitrates. Clear? Now let's see an example. Before moving on to the example, we can also use the dibar H instead of this tin chloride and HCl as a reducing agent. So what is dibar H? Dibar H is diisobutyl aluminum hydride. What it is? Diisobutyl aluminum. It is diisobutyl aluminum hydride. Okay. So here is the structure. You see formula diisobutyl group with aluminum hydride. So this is dibar H. Dibar H also converts this CN group to C double bond OH, CH. Clear? And coming to the esters. Once again. Okay. Okay. Esters are also reduced to aldehydes with dibar H. Okay, what is the formula for ester? It is R C double bond O O R. So this R C double bond O O R is also getting converted to RCHO on treatment with this dibar H on acid hydrolysis. Okay, this OR part will be converted to H so that you will get the aldehyde. So let's see some examples. So here R group is taken as C6H5 in the first example. On the CN part, on reduction with SnCl2 and HCl, it gives benzaldehyde. And the second compound, ester. So methyl propanate. So here we are having only one carbon, so it is called as methyl. And here in this component, 2 and 1 carbon we are having. So it is 3 carbon containing compounds basically, which is called as propanoate. Methyl propanoate gives propanal. Okay, because this OR, it will be converted to H, right? So we will get C2H5, CHO at the end. Clear? Then we'll move on to the third preparation, that is the preparation of aldehydes from alcohols. Okay. Primary alcohols on treatment with mild oxidizing agents like PCC gives aldehyde. What is PCC? PCC is the pyridinium chlorochromate. What it is? Pyridinium chlorochromate. It is one of the mild oxidizing agents which oxidizes the alcohol till aldehyde. Okay. It won't go to the further oxidation. That is, it will not lead to the oxidation of alcohol to carboxylic acids. Okay. So this PCC turns primary alcohol to aldehyde. Examples you see, ethanol is taken as an example. Ethanol is taken as an example here, and the 2-carbon containing alcohol gives the 2-carbon containing aldehyde. Okay. So what is the name of this alcohol? It is ethanol, and this is ethanal. Clear? So this is how we prepare aldehyde from alcohol using the mild oxidizing agent PCC. So far we have seen 3 preparations. Clear? The 4th preparation is from hydrocarbons. So from hydrocarbons, we prepare aldehydes using the reductive ozonolysis of alkenes. Clear? So what is ozonolysis of alkenes? Adding this ozone to the alkene first, then reducing it with the zinc metal in presence of water. So what is happening basically, this ozone is getting added to the double bond here, and it forms a 5-membered ozonoid like this. And on treatment with zinc and H2O, we get 2 different types of aldehydes. And for this example, we are getting the same type of aldehyde. Okay. So the simplest way to get the product from the reactant is, so break this C double bond C and add oxygen on both the carbons. You will get the product. We don't have to go through this mechanism at all. Okay. So just break this double bond, add oxygen on both the carbons, you will get the RCHO and RCHO part. Okay. 2 moles of RCHO you will get from this. Clear? So see this example. So 2-butene is taken as an example, and we are breaking the bond and adding oxygen on both the sides. So what we are getting at the last? We are getting 2 moles of CH3CHO, which is called as ethanol. Okay. And 2-pentene on treatment with ozonolysis forms 1 propanol and another one is ethanol. Because here we are having 3 carbon and here we are having only 2 carbon. Okay, finally we are getting 2 different products from this 2-pentene reactant. Here one is propanol, the other one is ethanol. This is the reductive ozonolysis of alkenes, from which we get the aldehydes. Okay. Now from the hydrocarbons, how to prepare the aldehydes from the hydrocarbons? First method we used ozonolysis, and the second method is Itard reaction. So what is Itard reaction? Basically, we take toluene as the reactant. So toluene has C6H5CH3 component in it, and this toluene on treatment with CrO2Cl2 and CH2. CrO2Cl2 is the chromyl chloride, and it forms aldehyde, which is called as benzaldehyde. That is, the CH3 part is getting converted to CHO part. Okay. So what is the mechanism? So take this component. First you add the chromyl chloride into it. So this toluene contains 3 CH bond in it, right? So toluene contains how many CH bond? 3 CH bond into it. So to this only we are adding the CrO2Cl2 component. So what you do? So insert this CrO2Cl2 between 2 CH bonds. Okay, insert the CrO2Cl2 between 2 CH bonds. You will get a chromium complex like this. So between 2 CH bonds, we have inserted the CrO2Cl2 component. Okay, so we got this chromium complex, and this on acid hydrolysis leads to the benzaldehyde. Okay, it's very easy. It's a very important reaction. Okay. And the next one, the third preparation from hydrocarbons itself is Gattermann-Koch reaction. So what is Gattermann-Koch reaction? Direct conversion of benzaldehyde from benzene. Okay, direct conversion from benzene to benzaldehyde using CO, carbon monoxide as a gas with HCl and anhydrous AlCl3 with copper chloride as the catalyst. So this catalyst and these reagents will convert benzaldehyde directly to, benzene directly to benzaldehyde. Okay, one of the very easiest reaction, right? Yes. Then the next one is using side chain chlorination followed by hydrolysis. So all these we are studying under the fourth preparation. Okay, that is from hydrocarbons only we are preparing all these things. So the fourth one is the side chain chlorination followed by hydrolysis. So take the toluene part again. Toluene is the aromatic hydrocarbon and treat this toluene with chlorine molecule in presence of H nu. What's H nu? H nu is the light, okay, light energy which we get from the UV radiation. Okay. And when you treat toluene with Cl2, it forms CHCl2 C6H4. So the name of this intermediate is benzyl chloride. Okay, this benzyl chloride on acid hydrolysis forms benzaldehyde. Clear? So it's one of the very easiest reaction. So from toluene to benzaldehyde using side chain chlorination followed by hydrolysis. Okay. So this is the commercial method for the preparation of benzaldehyde. Commercial in the sense in the industrial level for large scale preparation, they are using this method to prepare the benzaldehyde since it is the very easiest method. Okay. Now we'll solve some questions based on the preparation of aldehydes which we have discussed so far. Okay. So see the question. So how to convert 2-hexene to the product on treatment with O3 and H2O. So what happens when 2-hexene reacts with O3 and H2O? It's very easy, right? It is the reductive ozonolysis of alkene. So first we have to draw the structure of 2-hexene. Hex means 6 carbon. So first you draw the skeletal structure which contains 6 carbon into it. And between second carbon and third carbon, we have a double bond. So this compound is called as what? Then balance the remaining thing with the hydrogen. So each carbon should contain 4 bonds into it. So accordingly, you put the hydrogen and balance the thing. So now what we have to do? We have to break the bond, add one oxygen here and the another oxygen here. So what we are getting? This side we are having 2 carbon containing aldehyde, which is called as ethanol, or ethanol is otherwise called as acetaldehyde. Ethanol is the IUPAC name and acetaldehyde is the common name. And in the right side, we are having 4 carbon containing aldehyde. So 4 carbon containing aldehyde is called as butanol. So at the end, what we are having? Acetaldehyde and butanol. Okay, so which is the answer? So in the first option, it is given, no? Butanol and acetaldehyde. So that is the correct answer for this question. Got it? Now we'll move on to one more question. So this is very easy. All these are previous year's questions only. So such an easy question we are getting from this lesson. Clear? So let's try to solve this. So what is the name of this reaction? What is the name of this reaction? Just by seeing the reagent, we can able to find out the name of the reaction. So here it is palladium barium sulfate in presence of hydrogen, right? So what is this? Yeah, it is Rosenmann's reaction. It is Rosenmann's reaction. Fine. We'll move on to the third question. Identify the compound X in the following sequence of reaction. So just now we have seen the side chain chlorination followed by hydrolysis. So toluene with Cl2 and H nu, it forms benzyl chloride, right? So what is the formula for benzyl chloride? It is C6H5 CHCl2. Yeah, option C is the correct answer. Okay. Now, moving on to the fourth question. In the reaction CH3Cl plus 2 hydrogen in presence of HCl and ether gives X. And X on boiling with water forms Y. The term Y is. So what is the name of this reaction? Actually, it is Stephen's reaction. So CH3, C triple bond N. With 2 hydrogen, it forms that is, we have to break the bond and add 2 hydrogen like this, and we get CH3, CH, double bond, NH. This is compound X. Okay, and this compound X on treatment or boiling with H2O, it forms Y. So what is this? So this NH group will be converted to oxygen, right? So we will get CH3, CHO. What is the name of this aldehyde? It is 2 carbon containing aldehyde, which is called as acetaldehyde. So acetaldehyde is given in option A. Got it? So I hope everything which we have discussed so far was clear. And now let's move on to the preparation of ketones. So how to prepare the ketones? Again, from the acyl chlorides only. So aldehydes also we have studied this acyl chloride preparation, and then ketones also we are studying the preparation from starting with this acyl chloride. Okay, take this acyl chloride. 2 moles of acyl chlorides are taken, and it is treated with dialkyl cadmium. On treatment with that dialkyl cadmium, acyl chloride forms cadmium chloride and a ketone. Okay, this is the ketone part, and cadmium chloride is formed as a byproduct. Now, how to get this dialkyl cadmium? How to get this dialkyl cadmium? So you can get this dialkyl cadmium using hello. Yeah. So how to get this dialkyl cadmium using the Grignard reagent, which is RMgX. Okay. So from RMgX on treatment with cadmium chloride, it forms the dialkyl cadmium. Okay. And we'll see an example for this reaction. So CH3 COCl on reaction with ethyl magnesium chloride in presence of CdCl2 forms butane 2O, and the byproduct is cadmium chloride. Okay. So you can see the R group is CH3. 2 R group we are having, one is CH3 and the other one is C2H5. So at the end we are having both the alkyl groups attached to it, because in the general formula we have R dash, C double bond O and R, right? So one is R and the other one is R dash, and 2 moles of this is forming. And the second preparation is from nitriles and esters. So what is nitriles? R C triple bond N is called as nitrile. And this on treatment with RMgX and dry ether, it forms R dash C double bond O R. Okay. So what is this basically? We have to see the mechanism. So first the CN reacts with this RMgX and it forms R C double bond N MgX and R. That is, we are breaking this bond and adding R to the carbon and MgX to the nitrogen. So this forms this intermediate. And this intermediate with the acid hydrolysis forms acetone. Okay. This C double bond N, this whole group, I told you, no, in the Stephens reaction itself, we have discussed. The whole group gets converted to oxygen. Okay. So we'll get R dash C double bond O and R at the end. So similarly, Esters also react with Grignard reagents followed by hydrolysis to produce the ketones. Okay, so this is the ester, and this also reacts with C6H5MgX, and in the same mechanism it forms the ketone here, which is called as 1-phenyl-butanol. Okay, now let's move on to the next preparation, that is from benzene and its derivatives. So take the benzene and treat it with the acyl chloride or some benzoyl chloride. In presence of anhydrous AlCl3, it forms a ketone. And this reaction is called as Friedel-Crafts acylation reaction. So what is happening basically? We'll get RC double bond O as an electrophile here. This is one of the electrophilic substitution reaction, right? So we'll get RC double bond O as an electrophile, and that electrophile will go on and substitute one of the hydrogen which is present in the benzene. Okay. So let's see an example. So this is toluene, and to this toluene, here C2H5COCl component is added, and the C2H5CO, this is the electrophile, and that electrophile substitutes the para position and the ortho position. So why we are getting two compounds here? So the CH3 is the group substituted in the benzene. Okay, so the CH3 group is an electron donating group. If an electron donating group is attached to the benzene ring, the incoming electrophile substitutes, or it goes and attacks the ortho position and the para position. Okay, ortho means adjacent position and opposite means para position. So that's why we are getting two products. One is para substituted, the other one is ortho substituted. Para substituted is the major product and ortho substituted is the minor. Got it? This reaction is called as Friedel-Crafts acylation reaction, from which we prepare ketones from benzene and its derivatives. Okay. Now the next preparation of ketones is from alcohols. So secondary alcohols on treatment with mild oxidizing agents like PCC and we can call this as pyridinium chlorochromate, right? On treatment with this PCC, it forms ketone. We have discussed in aldehydes, if we take primary alcohol, we get aldehyde. And if we take the secondary alcohol, we get ketone. See, this is the secondary alcohol. RCH2OH is primary alcohol and RCHOH is called as secondary alcohol. So this secondary alcohol is getting converted to C double bond O. Okay, we get a ketone from this. So let's see some examples. So propan-2-ol is taken as an example here. So 1, 2, 3. The 3 carbon containing compound. So it is propan. And the second position we are having this OH group, which is called as alcohol. So it is called as propan-2-ol. And propan-2-ol on treatment with PCC, that CHOH part will be converted to CO. And 3 carbon containing ketone is called as propanone. Okay. Now let's move on to the summary part. So let's summarize what we have discussed so far. So we have to study the preparation of aldehydes from Rosenmann's reagent and from Stephens and PCC and ozonolysis. This is ITAD reaction and preparation of ketones. Some of the preparation of ketones are from dialkyl cadmium and this nitrile part, and last one is Friedel-Crafts acylation reaction. Okay, so these are some of the important concepts from the preparation part which we have discussed so far. Okay, now next we'll move on to the properties of aldehydes and ketones. Okay, there are two different properties, right? One is physical property and the other one is chemical property. So today, the second half, we are going to discuss the physical properties of aldehydes and ketones. Okay, and next the chemical properties of aldehydes. So in the physical properties of aldehydes and ketones, first, methanol is a gas. So what is methanol? Methanol means one carbon containing aldehyde, which is called as HCHO. So methanol is a gas at room temperature, whereas ethanol Ethanol means CH3CHO. Ethanol is a liquid. And ketones up to carbon number 13 are volatile liquids. Ketones up to 13 carbon system are volatile liquids. And more than 13, they are solids. Okay, and lower aldehydes have unpleasant smell, whereas ketones and higher aldehydes have fruity smell. That's why we are using those in the fragrance, the perfumes, etc. Right? So higher aldehydes, more number of carbon containing aldehydes and ketones are used in the fragrances purposes. And coming to the boiling point of aldehydes and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. Why it is like that? You see here. So this is the aldehyde, 2 carbon containing aldehyde, and this is the ether. Ether means ROR, which you might have studied, and this is the alkane part, hydrocarbon. Okay. When we compare 3 different functional group containing system which are of comparable molecular masses, aldehyde is having the highest boiling point value. So why it is like that? Because of the presence of intermolecular hydrogen bonding present in it. Okay, and also in the solubility, you see lower aldehydes and ketones are soluble in water due to the formation of hydrogen bond. See here, the lower aldehydes like 1 carbon, 2 carbon, up to 4 carbon, they are soluble in water itself because the R group is very small. So it can go, the corresponding aldehyde will go and form the hydrogen bonding with the water and they gets dissolved in it. So when the R group increases, when the size of the R group increases, so what happens? The tail part increases and the head is very small. So that the head cannot come and form the bond with the hydrogen and gets dissolved in it. Okay. So only the lower aldehydes and ketones are dissolved in water due to the formation of hydrogen. And the solubility in water decreases with the increase in the molecular mass. That is with the increase in the size of the alkyl chain. Got it? So this is about the physical property. And coming to the structure of carbonyl group. So you can see the structure here. So this is a structure. That is, we have carbon, double bond oxygen, and here R. And here also in this compound we are having R. If it is R, it is called as ketone. If it is hydrogen, it is called as aldehyde. Okay. So now we are going to study the structure of this carbonyl group. Got it? So first of all, moving to the sigma bond pi bond calculation. So around this carbon we have 4 bonds. In this 4 bonds, we have 1, 2, 3 sigma bond. And in the double bond, one is sigma, the other one is pi, right? So totally we are having 3 sigma and 1 pi, which you can see here. So this is the pi bond, which is formed by the sideways overlap of the carbon-oxygen orbitals, and the sigma bond is formed by the head-on overlap of the carbon-oxygen bonding. Okay, and the hybridization of this carbon is given as sp2. So hybridization of the carbon is given as sp2. Why it is given as sp2? Because it is double bonded carbon. All the double bonded carbon will have sp2 hybridization, right? If the hybridization is sp2, what is the geometry? Geometry is trigonal planar. Geometry is trigonal planar. You can see here. So it is trigonal planar in geometry. Okay. So the double bond between the carbon and oxygen is very shorter, but it is very stronger and it gets polarized. So this the carbon-oxygen bond, you can see it is double bond. So the length is very small, so it is short. But it is very strong because bond length is inversely proportional to bond strength. Since oxygen is more electronegative in nature, this bond gets polarized. That is, the more electronegative atom will pull the electrons towards itself, right? So this oxygen will pull the electron towards itself. So it gets a partially negative charge And as this carbon donates its electron to the oxygen, it gains a partially positive charge. So this carbon-oxygen bond is getting polarized to plus and minus. Clear? Carbon acts as an electrophile, which is otherwise called as Lewis acid, and the oxygen center is acting as a nucleophile, is called as Lewis base. Since this carbon gains the positive charge, this carbon is electrophilic in nature. So what are electrophiles? Electrophiles are electron deficient system. Electrophiles are electron deficient system. And these electrophiles, they act as a Lewis acid. Electron deficient systems are called as acids, right? So here this carbon center is acting as a Lewis acid. So electrophile can react with the nucleophile, right? So if a nucleophile comes, it comes and forms the bond with the carbon. And this oxygen center is acting as a nucleophile. So it is acting as a nucleophile. What are nucleophiles? Nucleophiles are electron-rich centers or rich compounds, which are otherwise called as Lewis bases. Got it? So what are the informations we have studied? The hybridization of the carbon and the number of sigma and pi bonds present in this carbonyl group, and the carbon-oxygen bond is polarized, which is shorter and stronger. Carbon center is acting as an electrophile and oxygen center acts as a nucleophile. Okay, this is about the structure of the carbonyl. So based on the structure, nucleophile prefer to attack the carbon. Okay, based on the structure, tomorrow we'll discuss about the chemical properties of aldehydes and ketones. Okay. So thank you everyone.